All right, we're looking at graphing quadratics today. So here's a quadratic function that's already graphed. Okay, now there's certain things about this graph that we can tell just by looking at the graph itself. First thing I notice on this graph, and let me get this over here a little bit better. Okay, first thing I notice about this graph, it's concave up. It's going up. It's concave up. Which means, since it's concave up, we have a minimum value on this. We have a minimum value down here, and my minimum value right here is 0. Okay, my minimum is 0. Now my vertex is this minimum or maximum point, whatever it is. On this one right here, it's -4, 0. This is my vertex. And this value right here would always be my minimum or my maximum every time. Okay? Now, we have what's called the axis of symmetry. The axis of symmetry is this line right down the middle of this thing that makes each side equal to that line. So like each point over here is equivalent to that point over here. This goes right down the center of this and divides into two equal parts. All right. Well, mine is located at -4. So x equals -4 is my axis of symmetry. And that will always be that value. Okay. So when you have your vertex, usually I just find the vertex first because that tells me my axis of symmetry and it tells me my minimum or my maximum value every time. Okay. Now, the next thing we have is my domain and range. Okay. My domain and range. My domain is all my x's. And so if I look at the x values on this, what x values does this graph have? Well, it has every x value. -infinity to +infinity. That's my domain. Because every value of x is represented in this graph. Now see how this goes up and it's got these arrows? That means it goes up and up and up forever, which means it goes over forever. Because as this thing goes up and up and up, it's going over. So this thing goes this way to the left forever, and it goes this way to the right forever. So that would be my domain, -infinity to +infinity. And this right here is going to be for every one of these graphs. Every one of these quadratics will always have the same domain. Always. Now the range is what's different. Range is up and down. Now let me write this on here. Domain is left and right. Okay, range is up and down. And so what you do is how far down does it go and how far up does it go? Well, if you look at this graph, how far down it goes right here, it goes down to 0. So 0 is the lowest value. Now it is included. So I'm going to put this little bracket. Okay, now what's the furthest up it goes? Well, it goes up forever. So that'd be infinity. And so that's my range. When you have your range, the lowest value or the highest value, depending on if it's a minimum or a maximum, you'll always have this bracket because that value is included. Now what I mean by that is that's a value that is a part of the function. Whereas, see here we put parentheses on these infinities because this is a value we never do get to. So it does not include that. So we put this parentheses because that's a value we never do get to. I don't know if that makes sense to you or not, but that's just how it is. Okay. Now, you have x-intercepts. I'm going to put this in parentheses. And you have y-intercepts. Okay. Now, for x-intercepts, let me just draw a little drawing over here. Okay. you could have one like this, and it does not cross the x-axis, which means you do not have any x-intercepts. You could have one like this that touches, and you have one x-intercept. Or you could have one that does this, and you have two x-intercepts. So on x-intercepts here, it's possible you have none, it's possible that you have one, it's possible that you have two. Okay. What do we have on this one? It looks like we just have one. It touches on that axis there, so this just has one x-intercept. Okay. So it has one x-intercept. Okay. What is that x-intercept? It's just x equals -4. Okay. Now the y-intercept, every one of these graphs has a y-intercept. It has one y-intercept. Now this one here, if you look at the picture, you can't tell what it is because it's going to be way up here somewhere. It's going to be like, this is going to keep going, this is going to keep going. I don't know, let's see if I can just kind of draw this, put this paper here. Okay, there's my axis going up, oops, going up and up and up and up and up. Here's this thing going up and up and up, and it's going to hit it way up here somewhere. Now what that value is, I have no idea. I can figure out what it is because see, on this axis right here, this is when x equals 0. Okay, see, x equals 0 on this axis. So I could put 0 in the equation and figure out what it is, but I don't have the equation for this one, so I really can't do that on this one. But anyway, this has one y-intercept. And every one of these will have just one y-intercept. But now x-intercepts, you could have 0, 1, or 2. But y-intercepts, you always have just one y-intercept. Okay? And so these are all the things we can tell about this graph right here. All right? Let's look at this graph. All right. What can we tell about that one? Okay. Well, let's get us another sheet of paper here. What can we tell about this one? All right. Well, let's do our vertex first. My vertex on this is 3, -1. That's my vertex. Okay, over 3 and then down 1. Right there's my vertex right there. Okay. Now, that tells me a couple things now, if you remember. That tells me, like, see how this is a concave down, which means we're going to have a max value here. See, my vertex is the highest value on this one. So that means my max is going to be this -1 here. Okay, my maximum value of this graph is -1. -1 is the highest value of the whole thing. Every value is below it. The max is -1. -1 is the highest. All right, so my vertex tells me that this right here is my max, and it also tells me that my axis of symmetry, x equals 3. See 3 right here, x, that goes right down the center of this, and it cuts this into 2 equal parts. So your vertex always tells you two things. It tells you your max or your min, depending on if it's concave up or concave down. Oh, I didn't have it on there, did I? This is concave down. So that means I have a max. So this is my max, and this is my axis of symmetry every time. So the vertex tells you these two things automatically. Okay. Now, what's my domain and my range? Okay, well, every one of these, the domain is -infinity to +infinity. That's the domain every time. Okay, what's the range? All right, the range is up and down. See, sideways, this thing sideways domain, it goes to the left forever, it goes to the right forever. Because as these things go down with these arrows, as this goes down, it's going over. As this one's going down, it's going over that way. So it goes to the left forever, it goes to the right forever. But my range is up and down. Okay, what's the furthest down it goes? Well, it goes down forever, negative infinity. What's the highest up it goes? Well, it goes to -1, and it does include it. So we always put a bracket on this high or low number, depending on if it's a max or a min. This is a max, so that's the highest. So I put a bracket on it because it includes that value. Every time you have domain and range, you have your low, comma, and you have your high. Okay, you always have your low value, you have your high value. Low value and my high value. And that's my domain and my range. Okay, now, about x-intercepts. X-intercepts. This one doesn't have any, does it? See, here's the x-axis, and it does not cross the x-axis, so this has none. What about y-intercepts? Okay, it does have one. And again, this one's off the graph, so we can't tell what it is just by the graph. We'd have to extend it on down. So if you just look at this here, I'll see if I can't try to draw it real straight and figure out what the y-intercept is on this one. So I'm going to put this paper on here, and I'm going to just continue this on down. Okay? All right. And then I'm going to continue my curve. My curve's going to be going like this, and I'd say it's going to hit about right there is what I would say. Now, I might be wrong. I might have curved it too much. It might be more down here. This might be more right. This is -7, -8, -9, -10, 11, 12, 13, 14, 15, 16. I'd say it's around -17 is what I would say. Somewhere around -17. Now, we might learn this later, but if you look at this right here, here's my vertex, which is 3, -1. So that means this is going to be x minus 3 squared and then -1. And since I go over 1, it's going down 2. I'm going to have a 2 in front of this. So this is what y is going to equal. So if I put a 0 in for x on there, if I put a 0 for x, this is going to be -3 squared, which is 9 times 2 is 18, minus 1 is 17. I think -17 is right. So it's going down. I didn't put a negative in front of there. So -19, actually. So it'd be 9, 18, 19, -19. So my graph is off still a little, but this right here, we're not going to have to worry about this right now. But I'm just trying to figure out what the y-intercept actually is. But we don't have to determine that. We just say we have one y-intercept. Okay, let's look at another one. Okay, on this one. All right, first thing we see on it, my vertex. All right, my vertex on this one is, looks like it don't go over any. It's down 4, so 0, -4. That's my vertex. Okay, this tells me two things. It tells me that my axis of symmetry, x equals 0. Right here at x equals 0, this blue line splits it up into 2 halves, 2 equal parts. So that's what this tells me. The -4 tells me that is this a min or a max? Well, it's concave up. See, this thing's going up, which means my vertex is the lowest value. So this is the minimum. And so my minimum is y equals -4. Okay. So the vertex tells me these two things. Tells me the axis of symmetry, x equals 0. Tells me the minimum, which is y equals -4. -4 is the lowest value of this whole graph. Okay, now what's my domain and my range? Or my domain every time, negative infinity to positive infinity. My range, all right, this is what's different on these. What's the lowest value it has? What's the highest value it has? Well, the lowest value is -4. And that's a bracket. I'm going to draw, didn't mean to draw parentheses. What's the highest value? Well, it goes to infinity. It goes forever. Okay. Now what about my x-intercepts? This has two x-intercepts, right here and right here. So it has two. What are they? Now, some of these might ask you what they are. Well, this one's x equals -2. This one is x equals +2. So those are this is what they are. But there's two of them, -2 and +2. What about my y-intercept? Okay, we always have one. There's always one y-intercept, and you can see on this one, it's right here, -4. Y equals -4 is my y-intercept. Okay. All right, one more. Okay. So on this one, first thing we look at is the vertex. My vertex on this one, -4, 5. That's my vertex. This is concave down. This thing's going concave down. It has a vertex of this, and this tells me my axis of symmetry. Right there. X equals -4. See at -4 here, there's a line at -4. It cuts this into two equal parts. And then my vertex tells me that, and it tells me my max or min in this one, it's concave down, so my vertex is a max. So the maximum value is y equals 5. All right, so whenever you have your vertex, it tells your axis of symmetry and your maximum. Your x is your maximum, is your axis of symmetry, and your y is your maximum or minimum if it's going concave up. This one's going concave down, so it's a max. Okay. All right, what's the domain? Every time. Negative infinity to positive infinity. This thing goes to the left forever, it goes to the right forever. What's the range? All right, the range is up and down. So the lowest value, well, it goes forever to negative infinity, down forever. But it goes up to this maximum value of 5. And we put a bracket there because it does include 5. So I put a bracket on it because it includes it. If it didn't include, I'd put a parentheses, which means it comes up all the way to 5 but doesn't touch 5. Okay. Now, what about my x-intercept? This has two x-intercepts. There's one right there. There's one right there. Okay, this thing has two. This one's between -6 and -5. This one here is between -3 and -2. But it has two x-intercepts, and so that's all we'll have to answer on that. What about my y-intercepts? It's always 1. Don't even have to look at it. Y-intercept is always 1. You can see here, as far as the picture right now, it does not cross it in the picture now. But if I extend this line down and I keep going with my graph, it's going to touch it way down here. Somewhere down here. So it is going to have a y-intercept. It always will. But in the picture as it was, it didn't have it. It didn't show it at that time. But it does have one. All right, so that's the things you can tell about the graph of the quadratics. So graphing quadratics, and hopefully you don't have any trouble, but if you do, just contact me and I'll help you any way I can. All right, so have a great rest of the day.